question number 3. Now, before solving the third question, I am sure that my students know this particular concept already, but I am just repeating for my students. Suppose, for example, this is my home, this is my home, this is my office, right? This is my home, the other side is my office. Every day I will travel from my home to office along the same path. If I travel every day from my home to office along the same path, what is constant? Distance is constant. If I travel every day from home to office, will the distance change? No, distance will not change. That means the distance is constant. We know that speed is given by distance by time, and in some of the problems what we solve, where will distance will be constant. If distance is constant, can I say that speed and time are inversely proportional to each other, right? Speed and time are inversely proportional to each other. I will come back to this concept after some time anyway. Again I will come back to this concept, but what I want to tell you is, if the speed increases, the time taken to reach the office will decrease, or if I decrease my speed, I should take more time to reach the office, provided the distance from my home to office is constant. Distance, if it does not change, speed and time will be inversely proportional to each other. I am sure that you know this concept already. Now see here, third question again is a very easy question. Let us solve all the easy questions initially to understand better, to take it forward for next level questions. Listen carefully, sir. Your third question is, a man walked at a rate of 4 kilometers per hour from point A to B. That means a person is traveling from A to B. Let us represent it via diagram. A person is traveling from A to B. A man walked at a speed of 4 kilometers per hour from point A to B and came back from B to A at the speed of 6 kilometers per hour. He is traveling back from B to A at a speed of 6 kilometers per hour. What would be the ratio between the time taken by man in walking from A to B and to B to A respectively? That means time ratio is what they are asking. Time from A to B and time from B to A. This particular ratio is what they require. It is very easy because we understood the concept behind solving this question. Can I say that from A to B he is traveling at a speed of 4 kilometers per hour. From B to A he is traveling at a speed of 6 kilometers per hour. Speed ratio is 4:6. 4:6 is nothing but 2:3, and the distance from this place to this place is constant. Distance from A to B is constant. If the distance is constant, speed ratio, if it is 2:3, time ratio will be the reciprocal. So time ratio will be 1/2:1/3. 1/2:1/3. If I take LCM and simplify, I will end up with 3:2. Time and speed are inversely proportional to each other, provided distance is constant. Again a very easy question, and we will understand the concept slowly as we proceed with some other questions. I believe that it is also very clear for you people, and I am very happy that many students are already answering the questions very fast. Keep having the same approach, sir. Keep doing it little fast so that you will not miss out in any questions in your examination. Please see this question. Again, not that of a difficult question. See this question. A bike covers a certain distance. That means the distance is constant, right? Distance is constant. A bike covers a certain distance at the speed of 64 kilometers per hour in 8 hours. That means, can I say that distance is nothing but speed into time. Speed is given as 64 kilometers per hour and time is given as 8 hours, right? Time is given as 8 hours. So distance that he needs to travel is 64 into 8. 64 is 2 power 6. 8 is 2 power 3. 2 power 6 into 2 power 3 is 2 power 9, which is 512 kilometers. Distance that he needs to travel is 512 kilometers, right? Distance that he needs to travel is 512 kilometers. What is the next statement? If the bike was to cover the same distance, he still needs to cover the same distance of 512 kilometers. If the bike was to cover the same distance in approximately 6 hours, what approximate speed should he drive a bike at? Now see here, sir. Now he needs to travel the same distance of 512 kilometers. speed is given by distance by time. Distance he still need to travel is 512 kilometers, and time earlier he was taking 8 hours. Now he needs to only take 6 hours to travel the distance. So it is 512 divided by 6. 512 divided by 6. It is 85.33 kilometers. But 85.33 is not there in the answer options. But the question is asking you for approximate value. Approximately the answer is 85 kilometers per hour. Answer for this question is 85 kilometers per hour. Keep listening to all the problems until it is completed, sir. First 15 to 20 minutes is a warm-up session. Then we will actually jump on to the original match. Just keep on having faith in this content and keep listening to all the classes. Do not worry about what is the level of difficulty at this point of a time. Just keep on listening. See here. This kind of questions has come in the examination multiple times. Using this kind of questions, we will also solve some of the very difficult questions in the most easiest way possible. Listen carefully, sir. Your question is, I will solve this question in two methods. Whichever the methodology which you are comfortable with, please follow that particular method. Now see here. Your question is, walking at 3/4 of his usual speed. Walking at 3/4 of his usual speed, a man is 12 minutes late in reaching his office from home. Find his usual travel time. Walking at 3/4 of his usual speed, a man is 12 minutes late in reaching his office from home. Find his usual travel time. Now listen carefully, sir. I will teach you two methods. The methodology whichever you are comfortable, please follow that method. Now see here. Suppose this is my home. Suppose this is my home. The other side is my office. Every day I will travel from my home to office along the same path. The distance will not change. That means the distance is constant. Now listen carefully, sir. Every day I will travel from my home to office along the same path, and every day I will travel with my usual speed of s kilometers per hour or s meters per second. Similarly, every day I will take t minutes to reach the office. That means usual scenario is I will usually take s kilometers per hour. S kilometers per hour is the usual speed what I travel with. Every day I will usually take t minutes to reach the office, and I will travel a distance of d kilometers. Now that is the first day scenario. Speed is equal to distance by time. Distance is equal to speed into time. This is the everyday scenario, right? This is the everyday scenario. But what is the question? Walking at 3/4 of his usual speed. Walking at 3/4 of his usual speed. Every day I used to travel at s kilometers per hour, but today because of some problem I am traveling at 3/4 of his usual speed. Because I am reducing my speed from s kilometers per hour to 3/4 of s, I will take more time to reach the office. How much more time I will take? A man is 12 minutes late in reaching the office from home. Every day s kilometer. Today I traveled at 3/4 of s, and therefore I took 12 minutes more than t. 12 minutes late is nothing but 12 minutes more I took. So that means speed is reduced, time is increased, but will the distance from home to office change? The distance will never change. Distance will not change. Distance will still remain d itself. So right hand side is still d itself. First equation, second equation. If I solve these two equations, right hand side of equation 1 and 2 are same. Equate the left hand side. Left hand side of equation 1 is s into t. Left hand side of equation 2 is 3/4 into s into t plus 12. If I simplify further, s will cancel out. Cross multiply. This is 4 into t is equal to, here also multiply. It is 3 into t plus 3 into 12 is 36. 4t minus 3t is nothing but t. T is equal to 36 minutes. But what is that they are asking you in the question? They are asking you the question, find the usual travel time. Usual travel time is denoted as t itself in my notations. So that is what they are asking you for. Actual answer for this question is t is equal to 36 minutes. T is equal to 36 minutes is the answer for this question. deliberation, but this is my method 1. Any student who is interested in solving by using this kind of methodology, you should never listen to Anil Nair classes YouTube channel. This is one of the very old methodologies which will kill a lot of time in our examination because it involves variables and it involves equations. We need to form two equations, solve those two equations, get the value of one variable, and if required we need to back substitute to get the value of another variable. Very time consuming process which we are not at all interested with. So let us not use this methodology to solve our problem. I hope method 1 is very clear, but not interested. This was your method 1. Right, this was your method 1. Let us not implement this methodology to solve our problem. Let us use a completely different analysis so that we will probably solve some of the questions without using pen, and that too conceptually without using any variables or formulas. Listen carefully, sir. Now, what is the question? Let us read the question once again. Walking at 3/4 of the usual speed, a man is 12 minutes late in reaching his office from home. Now, listen carefully. Can I say that speed is equal to distance by time, right? Speed is equal to distance by time. So distance is equal to speed into time, right? Distance is equal to speed into time. The question says walking at 3/4 of the usual speed. Speed is given as 3/4, and we know that distance from home to office is constant, it is not changing. If the distance is constant, speed and time are inversely proportional to each other. That means if speed is given as 3/4, time will be nothing but reciprocal or the inverse, which is 4/3, right? Time is nothing but 4/3. Now, what is the meaning of time is 4/3? Time is 4/3 is nothing but, listen carefully, sir. This is the very important point. Time 4/3 is nothing but, you have a numerator, you have a denominator. I have told this particular thing in so many topics of mine. I am repeating again for all the students who have not listened to my previous classes. You have a numerator, you have a denominator. Your denominator will always represent your initial value or the actual value or the usual value. All the notations are safe. Denominator will always represent your initial value or the actual value or the usual value, and I am talking about time. That means this denominator 3, it will represent the usual time taken, right? Denominator 3 will represent usual time taken. That means usually every day I will take 3 minutes to reach the office. Every day usually I will take 3 minutes to reach the office. But today I took how many minutes? Today I took 4 minutes to reach the office. Every day I will take 3 minutes. But today I took 4 minutes. Every day 3 minutes, today 4 minutes. That means I am late by how many minutes? I am actually late by 1 minute. According to this fraction, I am late by 1 minute. According to this fraction, I am late by 1 minute. But according to the question, in the question says he is late by how many minutes? He is late by 12 minutes. According to the fraction, I am late by 1 minute. According to the question, I am late by 12 minutes. 1 is becoming 12. Multiply by 12. 3 also multiply by 12. 3 into 12 is how much? 36 minutes. Usual time taken according to fraction is 3 minutes. So according to the question, my answer is how much? 36 minutes. I am not at all interested in teaching any problems in this method where you will form two equations, solve two equations, get the value of variables. We will completely use a different strategy to solve time, speed and distance problem. Probably will fall in love with my content in the next 1.5 hours of my class. I hope everyone is very clear with the logic which we have discussed, sir. According to the fraction, speed is nothing but given in the question as 3/4. So time will be 4/3. The meaning of time 4/3 is nothing but denominator will represent the initial value or the actual or the usual value. And I am talking about time. Usual time taken is 3 minutes, but today I took 4 minutes. That means I am late by 1 minute, but question says I am late by 12 minutes. 1 should become 12, multiply by 12. 3 also multiply by 12. 3 into 12 is how much? 36 minutes. I believe that every student listening to the class is very, very clear with the concept what we have discussed. I will take another question similar kind of it, where my students probably will try to sell the answer without using pen. See here, walking at 9/5 of his usual speed. Walking at 9/5 of his usual speed, a man is 44 minutes early in reaching his office from home. Find his usual travel time. Please do not use your pen. In fact, this question does not deserve a pen if you have understood my previous question. But probably I am using the pen for you to understand it. Speed is equal to distance by time. Distance is equal to speed into time. So walking at 9/5 of the usual speed. Speed is given as 9/5. Time will be how much? 5/9. What is the meaning of time 5/9? Denominator represents usual time taken. Usual time taken is 9 minutes. Every day I will take 9 minutes to reach the office. But today I took only 5 minutes to reach the office. Every day 9 minutes. Today I took only 5 minutes. That means I am early by 4 minutes. But the question says I am early by how many minutes? 44 minutes. 4 should become 44. Multiply by 11. 9 also multiply by 11. 9 into 11 is how much? 99 minutes. One of the very, very easy question. Only if you know the concept what we have discussed right now, you will be probably able to solve this question within 5 seconds of time. And that too, underline the statement, without using pen. I believe that it is very, very clear for you people. Ramana Venkat, walking at 9/5 of usual speed. Speed is given as 9/5. Time is reciprocal 5/9. The meaning of time 5/9 is denominator is nothing but usual time taken. Ramana Venkat, usual time taken. Every day I will take 9 minutes to reach the office. But today I took only 5 minutes, Ramana. So that means every day 9 minutes. Today I took 5 minutes. That means I am early by how many minutes? I am early by 4 minutes. 9 minus 5 is how much, Ramana? It is 4. I am early by 4 minutes. But question says I am early by 44 minutes. 4 is becoming 44. Multiplying factor is 11. 9 also multiply by 11, sir. 9 into 11 is 99 minutes. Ramana Venkat, I believe that it is very, very clear for you. Again, I will solve this question in two methods. Whichever the method you are comfortable with, please follow that method. First, let us read the question, understand the question, and then execute it. If the speed of a moving body increases by 37.5%, by what percent should the time be decreased so as to maintain the same distance? Now, distance is same. Distance is constant. Listen carefully, sir. Method 1, method 2. I am still in basic level questions. I will slowly go on to some examination questions. In fact, this kind of questions also has come in the examination multiple times. Listen carefully, sir. If the speed of a moving body increases by 37.5%, now speed increases by 37.5%. For all the people who has missed out my fraction to percentages class, in DI class or maybe in percentages class, kindly ignore this statement as of now. 37.5 is nothing but 3/8. Kindly ignore how it is 3/8 as of now. We know how it is 3/8 from our previous classes. If you are a new student who has not attended that class, ignore it for time being, sir. Right? Speed increases by 3/8. By what percentage should the time be decreased so as to maintain the same distance? Now, time should decrease because the distance is same, right? The distance is same. Listen carefully. I just now used one of the approach for you to teach this particular kind of problem. Denominator always represents initial value. First of all, speed into time is equal to distance, right? Speed into time is equal to distance. Initially, I was traveling at some initial speed. I increased the speed. Finally, I went at some other final speed. Initially, I was taking some initial time to reach the office. Because I increased my speed, finally I took some other time. Now, what is the question? If the speed of a moving body increases by 3/8, denominator represents the initial value, and I am talking about speed. So initial speed is 8 kilometers per hour, right? Initial speed is 8 kilometers per hour. What will be the final speed? If the initial speed is 8 kilometers per hour, final speed will be 3 more than 8. 3 more than 8. They are saying that there is an increase of 3 from 8. There is an increase of 3 from 8. Increase of 3 from 8. 3 plus 8 finally will become how much? It will become 11. So can I say that initial speed is 8, final speed is 11, and distance is constant. Speed and time are inversely proportional to each other, right? Speed and time are inversely proportional to each other. These 8 and 11 will become reverse. It will become 11 and 8, right? It will become 11 and 8. What is your question? By what percentage should the time be decreased to maintain the same distance? I need to decrease the time as of now, and same logic I will implement. Initial denominator always represents your initial value. Initial time is 11 minutes. Initial time is 11. Put it in the denominator. 11 is becoming 8. 11 is becoming 8. That means there is a decrease of how much? There is a decrease of 3. Put it that in the numerator. 3 by 11. I also told you one more logic to remember in percentages. If the denominator is 11, answer should be a multiple of 9. 9 into numerator. 9 into 3 is 27. Write down twice. Answer for your question is 27.27 percentage. Right answer for your question is time is decreased by 27.27 percentage. But you don't need to do all these intermediate steps and waste your time in the examination. You can actually get the answer within one step, and that too probably without using pen. That is what I will refer to as method 2 in this particular problem. I hope method 1 is very clear. In fact, in method 1 also we did not use any variable kind of methodology or a formula based methodology. We used a completely different method. But having said that, method 2 is something which will give the answer little fast. Now see here, sir, can I say that speed into time is nothing but equal to distance? Speed into time is the distance, and this distance is given in the question as a constant. It is given as the same distance. Distance is given in the question as a constant. Now listen carefully. If one of the parameter, preferably if right hand side is constant, and the product of two parameters is giving you a constant quantity, use this particular method. I taught you this method in percentages class in detail. Now they are saying that speed of a moving body increases by 37.5 percentage. Speed increases by 37.5 is nothing but 3 by 8. If speed is increasing, time will decrease, right? If speed is increasing, time will decrease. By what parameter will the time decrease? Listen carefully, sir. Can I say that here the numerator is 3. Don't change your numerator. Whatever numerator you have, copy paste the same numerator here also. Write down the same 3 here also. Now this question is consisting of increase, right? The question is consisting of increase. If the question is consisting of increase, you should add the denominator and numerator. What is 8 plus 3? 8 plus 3 is 11. If the question consists of increase, add the denominator and numerator and write down in the denominator. If the question consists of decrease, subtract the denominator and numerator and write down in the denominator. 3 by 11 convert back to percentage. It is 27.27 percentage. It is a one step answer compared to what we have solved in method 1. Method 1 also is one of the very beautiful method, but method 2 should give you the answer little faster compared to method 1 in this particular question. I believe the idea is very clear. So Sheila, you did not understand. Let me explain you method 2 with multiple other examples. Now see here, sir, for all the students, method 2 I will take 2 to 3 examples. Price increases by, suppose for example, price increases by 20%. Consumption should decrease by what percentage? Consumption should decrease by what percentage? To maintain the same expenditure, right? To maintain the same expenditure. Now question says price increases by 20%, 20% is 20 by 100, 1 by 5. If the price increases, consumption should decrease, right? Consumption should decrease. One of the right hand side parameter is constant. It is given in the question as expenditure is same. If that is the case, don't change the numerator. Whatever numerator you have, copy paste the same numerator. If the question consists of increase, add the denominator and numerator. 5 plus 1 is 6. 1 by 6 convert back to percentage. It is 16.67%, right? It is 16.67%. One more example for your better understanding. Suppose your question is length of a rectangle decreases by 60%. By what percentage should the breadth increase to maintain the same area, right? To maintain the same area. No need to use all those 100 and then increase by 60% or decrease by 60% and waste your time. Length decreases by 60% is nothing but 3 by 5. Length decreases by 3 by 5. If the length decreases, breadth will increase because the area is constant. Whatever numerator you have, copy paste the same numerator 3. Denominator, because the question consists of decrease, subtract the denominator from numerator. What is 5 minus 3? 5 minus 3 is 2. 3 by 2 is nothing but 150%. Answer for this question is 150%. Same ideology, whatever I discussed in these two problems, I have actually discussed in this particular question of time, speed and distance also. I believe that my students are very, very clear with the logic. Next question. I believe that this kind of problem solving is clear for my students. One more example before I move on to the next question of this sort. Suppose speed of a moving body increases by, suppose for example if I take speed of a moving body increases by 25%, by what percentage time should decrease to maintain the same distance? What should be the answer for this question, sir? I am sure that you can answer all these questions without using pen, with a little bit of practice. Probably you are using pen as of now, but I don't want my student to use pen to solve all these questions. Speed increases by 1 by 4. If speed increases, time should decrease. By what value it should decrease? Don't change the numerator. Numerator is 1 itself. If the question consists of increase, add the denominator with numerator. 4 plus 1 is 5. 1 by 5 convert back to percentage. It is 20%. I believe the idea is clear. First, let us read the question. A car covers a distance in 8 hours. That means a person is traveling in a car from A to B. The time taken for him to cover the distance from A to B is 8 hours. This is the first statement. Had the speed been increased by 4 kilometers per hour, the time would have been reduced by 30 minutes. If I increase my speed by 4 kilometers per hour, I will reduce the time by 30 minutes. Find the distance. Now I don't know the initial speed, right, sir? If I had the initial speed, I would have increased it by 4 kilometers per hour to get the final speed. But I don't know the initial speed. Now listen carefully. I will solve it in two methods. My students will pick up the methodology whichever they are comfortable with. Method 1. Speed into time is equal to distance. Speed into time is equal to distance. I am traveling at some initial speed. Time taken is 8 hours and I will cover some distance d. This is my equation 1. Second day, I am increasing my speed by 4 kilometers per hour. That means speed increases to s plus 4 and time, because the speed is increased by 4 kilometers per hour, time taken would have been reduced by 30 minutes. Earlier I was taking 8 hours. Now I will take 30 minutes less than 8 hours, which is 7.5 hours, which is nothing but 15 by 2 in fractions. But the distance will still remain the same. This is my second equation, right? This is my second equation. Same like my previous question, right hand side of both the equations are same, equate the left hand side. If I equate the left hand side, can I say that if I equate the left hand side, here the left hand side in equation 1 is 8 into s, left hand side in equation 2 is s plus 4 into 15 divided by 2. That divided by 2 I will cross multiply to the left hand side. So if I finally simplify, 16s is equal to 15s plus 60, right? Plus 60. 15s, 16s minus 15s is s. S is nothing but 60 kilometers per hour, right? S is nothing but 60 kilometers per hour. Now I know the speed as 60 kilometers per hour after solving two equations, and I know the actual time as 8 hours. So distance is nothing but, substitute s in equation 1. Equation 1 becomes 60 into 8 is equal to distance. So distance will be how much? Distance will be equal to 60 into 8, which is 480 kilometers. What all students will do to get the answer as 480 kilometers, sir, which does not deserve a pen. This question really does not deserve a pen if you are a student of ANIL NAIR classes and if you have practiced much more better. Listen carefully, sir. I will not be interested in solving using method 1, which involves equations, and I need to solve that equation, get the value of a variable and back substitute in any one of the equation to get the value of another variable. Time consuming process, not at all interested. Listen carefully to my method 2. Listen carefully to my method 2. Can I say that had the speed been increased by 4 kilometers per hour, the time would have been reduced by 30 minutes. Earlier time is 8 hours. Can I say that? I am talking about time parameter as of now. I am talking about time parameter. You have a numerator, you have a denominator. I just 5 minutes before told you this statement. You have a numerator, you have a denominator. Your denominator will always represent your initial value. Initial time taken is 8 hours. Put it in the denominator. So simple logic, sir. Why are you using this methodology? Put it in the denominator as 8 and numerator is, if the speed is increased by 4 kilometers per hour, time would have been reduced by 30 minutes. Initial time is 8 hours. If the initial time is 8 hours, final time will reduce by half an hour compared to 8 hours. How much ever it is reducing, put it in the numerator. Denominator will always represent your initial value. Numerator will always represent how much increase is happening or how much decrease is happening. Here there is a decrease of half an hour, so put that 0.5 in the numerator. So can I say that time decreases by 1 by 16, 0.5 is 1 by 2. If the time decreases by 1 by 16, speed should increase by what value? I already taught you this particular concept 5 minutes before. Don't change the numerator. Numerator, let it be 1 itself. If the question consists of decrease, subtract these two. 16 minus 15 is 16 minus 1 is 15. That means speed increases by 1 by 15. The meaning of 1 by 15 is initial speed is 15. There is an increase of 1 kilometers per hour speed, but the question says there is an increase of 4 kilometers per hour speed. Question says 4 kilometers, but fraction says 1 kilometers. So make it to 4. Multiply by 4, divide by 4. That means speed increases by 4 by 60. Both are absolutely same. The meaning of 4 by 60 is initial speed is 60 kilometers per hour. That is what I got here also in method 1. Initial speed is 60 and initial time is 8. So distance will be 60 into 8. Overwrite. Where am I using the variables or fractions? What is that? Equations here, sir. In fact, I am damn sure that you can solve these kind of questions definitely without using pen if you have practiced better. I am repeating, if you are not satisfied with this method, I am repeating, this is one of the beautiful method where you can have initial value in the denominator. Numerator is always how much increase or how much decrease. Yes, method 2 is not clear. Yes, I believe you have listened to my previous problem. Yes, right, I believe you have listened to my previous problem. I am repeating one more time for all the students for whom method 2 is not that clear. Listen carefully. Initially question says a car covers a distance of 8 hours, distance in 8 hours. Initial value should always come in the denominator. Initially it is taking 8 hours to cover the distance. Put that 8 in the denominator. Put that 8 in the denominator. Can I say that had the speed been increased by 4 kilometers per hour, time taken would have reduced by 30 minutes. Initially it was taking 8 hours. Final speed, there is a decrease of half an hour. Whatever the value it is increasing or decreasing, put it in the numerator. 0.5 is 1 by 2. 1 by 2 into 8 is 1 by 16. So time decreases by 1 by 16. Speed should increase by what value? Don't change the numerator. Write down same one. If the question consists of decrease, subtract these two. 16 minus 1 is 15. The meaning of speed 1 by 15 is initial speed is 15. Right? Initial speed is 15. There is an increase of 1 kilometers per hour speed. But question says there is an increase of 4 kilometers per hour speed. Make that 1 as 4. Multiply numerator by 4. Multiply denominator also by 4. 1 by 15 can also be written as 4 by 60. That means speed initially is 60 kilometers per hour. That is what I got in method 1. Time initially is 8 hours. Distance is 60 into 8. Rajkumar, I repeated again, sir. Yes, I also repeated for you. I believe that it is very clear right now. No methodologies which involves this left hand side methods what I have discussed. And if you want that kind of methodologies, probably you should quit our YouTube channel.